So, a couple things. I guess there's two different things that I want to make sure you can do. I want to make sure you can find arc length and area of a sector with both degrees and radians. Okay? And I'm going to show you where these formulas come from. Okay? Most of the time in the real world, you're going to deal with degrees. Okay? So arc length, I think both of these are really common sense formulas, and I don't know why this thing. Let's go like this again. So arc length, the book's called S. Here's the way I do it. It's how much of the circle am I interested in? What proportion of the circle am I interested in? Times my circumference. It's what piece of that outer rim am I interested in? Does that make sense? It's a very straightforward formula. It's a very straightforward idea. Okay? But I also want you guys to be able to do this in radians. So one thing you'll notice is that hanging out right here, look at this. 2 pi over 360. What is that? They cancel, right? Because that's radians, right? There's 2 pi radians and 360 degrees. So if I take 2 pi times 360, or if you want to do it this way, I go 180. Look at that. Degrees times pi over 180. Degrees times pi over 180 gives us radians. So that is why our formula works for theta times radius. Radians times radius. They're both the same formula, just the conversion factor from one to the other is built in. That make sense? Okay. So if we look at area, sector area, we can do the same thing. And this we didn't have a chance to get to yesterday. To successfully finish your assignment today, you need to use one of these two formulas. So the area of the sector, I like to go ahead and draw a little picture so I can note what I'm doing. Area of a sector is equal to, it's the same idea. The degrees over 360 times what? Pi r squared. Okay? That is, it's just the slice of the pie that you want. Okay? So now we got to do a little bit more work here to tease out this radians idea. So if I go degrees over 2 times 180 times pi r squared, do you see the degrees to radians conversion? Yeah, it's hanging out right there. Degrees times pi over 180, that's radians. So your area is 1/2, and most of the time the books will write it the r squared first, and then the sector, and then your radian measure like that. Okay? So you need to be able to work with these in both forms. Okay? If it's in degrees, okay, degrees over 360 times my area, done. Boom, boom, boom. Or you can convert your degrees to radians and just use this 1/2 r squared theta. That's the area of a sector. Okay? So, Rolla, here you go. I know the end of the video that you probably got online and made sure to watch yesterday got cut off. So here is what we did yesterday. And I did say I was going to give you, that was going to basically be a 2-day deal, right?
Yeah.
You already what? Good job. Did you look up and find the 1/2 r squared theta formula? Oh, the other one? The degrees? Okay, that's fine. Yep. Whichever one. Which I really like to bed all my formulas in something that we can remember. The proportion of the circle that we need. So, Okay? So that's it, the shortest video of the year.